Welcome back, guys. Today we'll be continuing where we left in the previous video, and we will learn the application part. All this we are learning when we'll come to the machine learning part, and you will be able to connect all the dots and all the concepts we have learned when we're learning in the maths part. Then we use in the machine learning. Okay, let's start with the topic. In the last video, we were discussing. Uh, Given like some data points, how can we draw a decision boundary which will separate the our data points. Uh, so let's say if we have something like this, we have some data points here, and some data points maybe here. So how can we draw a decision? This is called as, this line is also called as decision boundary. Okay, and this part is also called as class, like we will be calling it as class 1, and this we will be calling as class 2. So this is also we can call as feature 1, and this is feature 2. So these are some of the basic terminologies. And okay, so if this is the line, its equation will be y is equals to mx plus c, which we learned in the previous lecture. And what is the overall problem called? We learned in the overall problem, what we are trying to do is called as classification problem. So this is a small recap of what we did here in the previous class. Now, the problem we were facing was that in creating a decision boundary in which the line is best for, like which line is best for decision boundary. So, so let's say if we have something like this, so say here some data points, and here some data points. So which line? Let's say this is a line A, B, C. Which line among them is best for decision making or separator or decision boundary? Please comment these things. You will get the habit, like you will learn more. And why do you think, if it is A, why do you think A or B or C? Please comment that in the comment section. Coming back to so if you think intuitively, you will say, okay, A is better for decision boundary because what is the first thing we'll see is that from this line the data points are separately separated properly and equidistant. If you see line C or line B, these are not properly separated. So that is intuitively we can see here. But for machine, it will not get these logics. So machine only purely works on numbers. The first thing we need is the capability to compute distance between the line and the points. And in general, here we are taking example of only 2 features. In real life, there will be multiple features, right? So n number of features. So in that case, we will be using an hyperplane to separate our data points. So in general, we need the capability to find a distance between a hyperplane to any particular point. Okay. Now, since we are one step ahead with our solution, let's see how can we do that. So now the equation we have already seen is y is equals to mx plus c. Also, we discussed that equation slope of the line is m, which is delta y by delta x. That is small change in x and small change in delta y. Okay. Before moving to forward, let me ask you a question, and you can solve it when pause the video and solve that question, and please answer that into the comment section. Okay. So given, let's say, if you the equation of line is y is equals to mx plus c, and there is a line parallel to it, and its equation is 0.5 is equals to y minus x is equals to 0. What will be the value of, want to calculate the value of m? So please pause the video and solve this question. I hope you solved the question, and if you not, let's solve it together. So we said that equation of the parallel line is equals to x is equals to 0. So we want to convert it into the form of y is equals to mx plus c. So how can we do that? Let's move the x on the other side and divide it by this. So it will give us 10 by 5 2x. So it is the form of 2x plus 0. So here the value of m, since both the lines are parallel, so the slope will also be same. So m here will be 2. Let's solve one more question, and again please pause the video to solve it. So let's say there are two perpendicular lines. There are two lines which are perpendicular to each other, and one of the equation is this. We have to find m for the other line. Can you please solve it? Okay. I hope you solve it. If not, let's solve it together. And so if you remember in the last lecture, we have discussed one property of perpendicular lines where m1, the slopes of two perpendicular lines are, if you multiply them, equals to -1. So now, if we want to the slope of m2, we can say m2 is equals to -1 by 2. Simple, right? So that is the basics, some of the basic problems. Let's now move on to some other topic. In the last video, we also discussed that the general equation of line is also a plus by plus c is equals to 0, and we have converted into the machine learning concept where w1 and x1, where w1 is the weights and x1 are the features, right? And if we have to write it in hyperplane, we can say something like this: w0 is equals to 0. So this is our equation of the line or hyperplane. If the number of features are, if there are only 2 features, then it will be plane. If there are only 1 feature, it will be a line. 2 feature, it will be a line, and then there are 3 features, we have plane. So in linear algebra, we represent the weights as vectors, and vector will always be defined in format n cross 1. So by default, we will assume that the vectors will be defined in n cross 1, where so let's say if we have vectors a, b, c, d, if I have to represent in matrix form, we will always write it like this. Okay. So in our equation of hyperplane, there are 2 vectors. Right? So in our equation of this hyperplane, we have 2 vectors, right? Our weights and features. So if you want to represent both, so we can write something like w1, w2, w3, and w and w2. Right? And here it will be x1, x2, and x3. So n equals 1 and equals 1. You can represent into something like this. Now, let's say if I want to multiply why we want to multiply this? We present the above equation in vector form. This equation we want to represent in the vector form, so that we want, and this is the what we have done, right? We are multiplying weight next one feature and another weight with one feature. So we want to do a matrix multiplication. So to do that, we need to, since these two matrix will not be able to we will not be able to multiply, we need to do a hack where we want to take the transpose of one of the vector. So if we, let's say, take transpose of the weights, and then we will do something like this, then we will be able to multiply the vectors. And if I do add the bias or constant here, this is what our hyperplane equation is. Again, this is another representation of that, but in the vector form. Now, if we represent this in this way, this will give the above equation, right? This will give the our hyperplane. So we will represent weight vector as W vector, and our feature vector as X. And W is our scalar value, the scalar. So, and X belongs, so since, and we can say that since this W naught belongs to real number, and which have the value and values, and same thing about the weights, X features as well. So if we now represent this whole thing as W in a vector format, something like this, so we can say Wx dot plus W naught is equals to 0. And this will be transpose, since we are taking the transpose. So this is a transpose of this. Now this equation you will use excessively in the machine. You will see this equation everywhere. Okay. Now here Wx1 plus W2x2 and Wnxn plus W naught. This whole part is also called as dot product between W and X. Some like this we can also call as indirect product as well. Right? So let's explore more on what is a dot product. We can define dot product between A and B as A1 plus B1, A1 B1 equal B2, and AN plus U. So this is what we can represent it. Or we can also say that A dot B is summation of A I B I from where N1 to N, where is but for 1. In some of the cases, this dot product is also represented as this, but it is rarely used. Maybe if you read some research paper or something, you will come across this kind of representation, and you can assume that it is a. Okay, so we have done so. Just for practice, is find the dot product of these two vectors. We're going to find the dot products between and solve it using pen and paper. So we have reached the end of the lecture for this video. In the next video, we'll learn more about the geometric inclusion of vectors. So this is just a very high level discussion on dot product, and you will see that these things will be utilized when we start connecting all the concepts into one topic. Remember, we are solving a problem in the starting where we want to classify fish, right? So we'll use all these concepts to do that. So see you in the next lecture, and keep learning and stay tuned for the next video. Thank you.